Now, when we look at the start of geometry, is that just making sure we know our definitions that exist, and all these definitions have been around for thousands of years, and this is what we've got. We are going to make sure we can use this terminology correctly in our geometric proofs. So, firstly, like we're looking at the idea of a point. Point has position, has no size, so there's no thickness to a point. So it's just a point. It's just a position in some sort of space there, and we usually give them capital letters there. So it's a convention. Doesn't have to be the same all the time, but generally that's what you'll see. Now, a line is an infinite collection of points. It's only in one dimension, so again, it has got no thickness. It's only goes in one dimension. It's through two given points, and there is only one. There is one and only one straight line through those 2 points there. So, a line basically goes on. It goes on forever. Now, the next two is we often call these ones as lines as well, but technically they're not lines. Interval is a part of a line between the 2 points. So it actually stops. So an interval stops at between 2 points. But a lot of times that gets called a line. So just be wary. And also a ray as well. A ray is basically starting from one point and moving off in a direction and goes on forever. A line goes in both directions forever. A ray only goes in one direction forever there. So there's a difference between a line, an interval, and a ray. But really, all three of them get called lines. So just be wary. The term collinear. Now, we've probably seen collinear a bit when we've done coordinate geometry earlier on the year. And collinear points are ones that lie in the same straight line. So in coordinate geometry, we talked about them being having the same gradient between x, y, and y, z. So they're all in the same line. And that's what we call collinear points together on the same line. Concurrent lines mean they go through the same point. So we've got line L, M, and N here, and they go through the same point, and they're concurrent because they're together through the same point. So, and you can see here how we're labeling the lines with little letters. We often do that. That's a convention as well, is to label the lines with small letters. Points with capital letters, lines with small letters. We should know what a midpoint is, but a midpoint is the interval. Point divides the interval into equal segments. So hopefully we remember that. And any line through the midpoint of an interval bisects that interval, so it cuts it in half. So, and if it meets it at a right angle, we call that a right bisector. So a perpendicular bisector or a right bisector, because it cuts it in half and it meets it at 90 degrees. So there's some terms we're going to face in the geometry that we're going to do and in the problems we're going to do, and these are the terms you're going to have to use to solve these, to explain your work in geometry, because that's what it's all about. It's about explaining your work in this topic, and it's about giving reasons for why certain geometric principles are existing, or why two things can be equal or concurrent, or two triangles are congruent or similar. You must give reasons every time. If we don't give reasons, we're not going to get a complete solution, and that's what we have to prove. It's called deductive geometry because we need to deduce certain facts and prove more ideas through facts that we're given and being able to use to complete those proofs.